Welcome to Calbeckistan, the place where anybody can learn math. I'm Mr. Calbeck, and today we're going to be talking about the inverse trig functions. The inverse trig functions are the things that are going to allow you to get x by itself when it's inside a trig function. As a quick reminder, this does not mean tangent times x. This is tangent of x. It's a whole new operation of math, and so we're going to need some whole new math to be able to undo that and get that x by itself. If you've already learned this in your geometry class or in other classes, I recommend you watch this anyway because I think it's going to be explained in a different way and will help you understand exactly why it works. There's not a lot of teachers teach it this way, but I think it's really helpful. So if you've already learned this, go ahead and watch it anyways because I think you're going to learn something anyway. So here's what we're going to look at today. This is the situation where you might need an inverse trig operation. Okay, so here's the problem. If I wanted to set this up, I could use tangent to represent it because I have an angle, I have the opposite side. Remember, I draw a line directly from my angle to find that. So this has got to be the opposite side. The hypotenuse is up here because it's across from the right angle, and the 16 is the adjacent side. So if I were to set this up, I would say tangent of x equals the opposite over the adjacent, 12 over 16. Unfortunately, I don't know how to find x. Remember, tangent, this does not mean multiplying by x. I can't divide both sides of a tangent. What the heck do I do? How can I get the x out of this tangent? Okay, and I'm going to show you, I think, a helpful trick that will help you understand what we're going to do here. I'm going to take you through a little journey of your mathematical careers. You've done x. If you wanted to solve for x in this situation, most of you could do it in your head, but if you wanted to do the algebra the way your algebra teachers wanted you to do it, you'd have to subtract 2 from both sides. The question a lot of you may not have asked is, why am I subtracting? I mean, you sort of understand that it kind of vaguely cancels it out. I get a lot of answers like that, or it makes a 0, and these are all correct answers, but there's a more general reason. There's a relationship between addition and subtraction that you've got to understand in math. They're opposites. The math word we usually use is called an inverse. Okay, so you're going to use the inverse or opposite operations in math. And you see this throughout. If you have 3 times x equals 18, well, that's multiplication. What's the opposite? What's the inverse of multiplication? It's division. That's why you divide. Yes, it cancels out. But the reason that it cancels out is because it's the inverse or opposite operation. And this is true no matter how high in math you go. If you have a square and you want to get rid of the square so you can get x by itself, you need to do the opposite of a square, which is a square root. No, this doesn't equal 4, it equals plus or minus 4. Talk to your algebra teachers if you didn't learn the plus or minus piece. The point is, though, that the square and the square root, they cancel out. They're opposites. Okay, and every single math operation has one. Now here, I've got the tangent of x. So I need an opposite for tangent. I need the inverse tangent. Unfortunately for you, it's already built into your calculators. If you look at your calculator, directly above the tangent in the second function is something that looks like this. You'll see the button here. Here's the tangent button. And then above it, in a different color, is something like this. Looks like tan to the -1 power. Okay, that does not mean tangent to the -1 power. This means the inverse tangent. Okay, it's the opposite of tangent. And if we think about what the opposites always do, the opposites get the x by itself. When I have a square and I square root it, I get the x by itself. When I've added and I subtract, I get the x by itself. When it's 2x and I divide by 2, it gets the x by itself. So if I want to get the tangent, or if I want to get the x by itself, I need to do the opposite of tangent. And what I'm going to do here is I'm actually going to do the inverse tangent to both sides. Do the inverse tangent of x, lots of parentheses here, but this is going to go inside the tangent. Just like something goes inside the tangent, the inverse tangent is also going to have a parentheses. And I'm going to put that whole thing in there. I need to do the same thing to both sides, so I'm going to do it over here as well. 12 over 16. But check this out. Because inverse tangent and regular tangent are opposites or inverses, they cancel out, leaving you with just an x. Which means you have something that you can now type into your calculator, the inverse tangent of 12 over 16. I would recommend that you leave that as a fraction as often as possible. So it should look like this on your calculator once you've got it. And what that gave you is x, which was an angle. It was 36.9 degrees. Okay? 36.9 degrees. Now again, the reason that this works is because of this whole concept of an opposite. Opposites cancel things out. The opposite of tangent is inverse tangent, which is why they cancel out, leaving you with the x by itself. Always in math, look for the opposite when you need to get an x by itself. Okay? If you can stick with that in your brain, you're going to be able to solve literally any problem as long as you know what the opposite actually is. Okay, let's see if we can look at this a little bit more generally. So here we've got the tangent of an angle. We talked about this in lots of previous videos. But tangent takes an angle and gives you side lengths. So what do you suppose the inverse tangent would do if it's doing the exact opposite? The opposite of tangent would take side lengths, the opposite over adjacent, and it would give you an angle. Okay? So if we're looking at what an inverse tangent does, is it takes side lengths and gives you an angle instead of taking an angle and giving you side lengths. It's the exact opposite, and they cancel out, which is why you get x by itself. Now the same is true for sine and cosine. The inverse sine is the opposite of sine. The inverse cosine is the opposite of cosine. We'll do a quick example here with one of those so that you can see how it works. So here's your new triangle. Again, same thing that we looked at before. We have a missing side length. So our inverses will help us out. And I'd recommend when you're starting this, write whatever trig function comes to your mind. So if I have an angle here, I want to find this one. That's the opposite. So opposite and the hypotenuse, which one based on SOHCAHTOA gives you opposite and hypotenuse. Sine does. Okay? So I'm going to be writing sine of alpha. Again, that's just a variable that we use to represent angle measures. Is going to be equal to the opposite over hypotenuse. Okay? Got to get the variable by itself. I need the opposite of sine. The opposite of sine is the inverse sine. So I want to do the inverse sine to both sides. Again, that's going to go in here like this. And then to the other side as well. The inverse sine and the regular sine cancel out. Just like every other opposite operation, leaving you with alpha equals the sine of all of that, or the inverse sine of all of that. And you find the inverse sine the same way you found the inverse tangent. It's the second function of sine. So you type that in and leave the fraction in your calculator, and you're going to end up with an angle measure of 45.5 degrees, 0.6. Okay, don't forget your degree symbols. So we have 45.6 degrees there. And again, you could actually think about this more directly if you really understand the inverse sine function, because remember the inverse sine is going to take a side length and give you an angle. So you can actually go directly from that. If you're careful, you can find the opposite and the hypotenuse, and you can say, okay, well, I need to find the angle, and the function that gives me the angle is the inverse sine, which means you could directly go to this and say, okay, the inverse sine, that's going to give me an angle. It's going to give me alpha. I just need to figure out what goes in there. It's going to be 20 over 28. So as you get good at this, you're not going to need to do the canceling out process. But what you can do is jump directly to here. A lot of teachers teach this right away, but I think it's really important to understand the relationship between sine, inverse tangent, etc. Okay, and again, the same would work with cosine. That's it for today. Good luck with your homework. Shoot me any questions in the comments, or if there's any other pieces of trig you want me to get a video for. This has been Mr. Calbeck. This is Calbeckistan. I don't know, what do I even say? Hey, go do your homework.